Alright, so hopefully you've watched the first video, which we talked about method number 1, proportions. Now we're going to talk about method number 2. Method number 2 is where you've got basically a fraction that you need to find a not a common denominator. Alright, and so you need to get rid of that fraction. You're wanting to get rid of the fraction, so we're going to talk about that. So we're going to flip the page over. We've done all these. Those are on the back. So as you can see, it's kind of like when we added and subtracted fractions. So here we've got two fractions, or three fractions actually. None of them have common denominators. So we've got to figure out how to get rid of this, how to get rid of the denominators. We cannot cross multiply because this has more to it than just, if it was like this, if it was a proportion like this, we could cross multiply, but we've got this extra business going on over here. So the first thing we want to do is get rid of that denominator. So you have to basically multiply everything by what's going to cancel out. So I'm going to multiply, what would I multiply that would reduce all of these to remove the denominator. So I'm looking, this has a 3, this has an n, this has a 6. So I know if I multiply everything by 6, that will basically cancel this out to get 2, cancel the 6 out to get 1, but what about this n? I need to multiply everything by n as well. We're just going to get rid of those denominators. So basically I'm going to have 6n times 4 divided by 3 minus, and if you need to put the 1 under there, do that, minus 6n times 7 over n. I'm distributing this to each of these. Even the number on the other side of the equal sign. Okay, I'm multiplying this to everything, I'm distributing this to everything. And the reason is you're going to see when I multiply these out, I'm going to be able to get 8n here, because I can divide 6 by 3. I'm multiplying here. I can divide 6 by 3 and get 8n minus, here the n's cancel out, so 6 times 7 is 42, equals, the 6's cancel out, and I'm left with n on that side. Now I can just solve this as a algebra problem again. So I need to get my numbers on one side of the equal sign, my variables on the other. So I'm going to just, since this n is already over here, I'm going to subtract by 8n. Negative 42 equals negative 7n. N minus 8n is 7n, negative 7. Negative 7 divided by negative 7. And yes, to get n over here and 6 over here. So n would be 6. I'm going to look back and just double check and make sure that that's correct. If I have 4/3 minus 7 over 6, does that equal 1/6? To get this to be, excuse me, to get this to be like terms, I'd have to multiply the numerator and the denominator by 2 over 2. 8 over 6 minus 7 over 6 does equal 1/6. So check. Okay, so now let's do number 9. So now we've got binomials. in the bottom, in the denominator. So we still need to get the denominators the same. So we're looking at that and we're saying, okay, what kind of denominator do we need so that they all can be the same? And we can kind of notice that this is a perfect square binomial. This is a perfect square. This one's a perfect square. So we can factor that right into p plus 2, p minus 2. And when I do that, I notice that I've got this in common for those two. So what I'm going to want to do is multiply, but I also notice that this 2 right here does not have a denominator. So in order to have that be the same denominator, I'm going to have to multiply it by everything. It doesn't have a p minus 2 or a p plus 2. So I have to take this first. I'm going to multiply p plus 2, p minus 2 times everything in here. So when I multiply it by p over p minus 2, I can cross, well, and then I'm going to multiply p plus 2, p minus 2 times 2 equals 8 over p plus 2, p minus 2 times p plus 2, p minus 2. So here's what I'm doing. I'm multiplying everything in this equation. So this by this. And I'm multiplying this, and I'm multiplying this. And I'm multiplying each of those by this common denominator. And the reason why I'm doing that is so that I want to get rid of the fractions. I'm trying to get rid of the fractions. So if I were to kind of put this in a little bit easier numbers, if I was to take 1/3 plus 2/4 equals x over 12, and I multiplied by, and I'm kind of saying that this denominator incorporates some of these, I multiplied everything by 12. I'm going to get 12 over 3 plus 24 over 4. Do you see I'm multiplying the numerator times the numerator equals 12 over 12, 12x over 12. Now I can reduce that to a whole number. That basically is going to get rid of my denominator, because now 12 divided by 3 is 4. 24 divided by 4 is 6. 12 divided by 12 is going to be x. 10 would equal x in this situation. I'm manipulating the numbers to get rid of the denominator. I'm doing the exact same thing here. So when I multiply these, I can now cross these out, and I'm left with p plus 2 over p, 9 times p, plus, this should be a plus, plus 2 times p plus 2, p minus 2, equals, and then these cross out, 8. Now the benefit is I have no fractions. So I can now just distribute, and I'd be getting, so I distribute this, p squared plus 2p plus, I'm going to have to multiply that out, and I would get 2 times p squared minus 4 equals 8. If I distribute that 2p squared minus 8 equals 8. Then combine my like terms, p squared plus, 3p squared, because I've got these two like terms, plus 2p minus 8 equals 8. Now I need to set this equal to 0. So I'm going to subtract 8 from both sides, and I get 3p squared plus 2p minus 16 equals 0. Now I can do my x. Negative 16 times 3 is negative 48. 2, so I know this is going to be 8 and negative 6. Divide by 3. And I'm going to be left with 3p plus 8 is this one, and p minus 2 is that one, equals 0. So this is factored into these. Now I set those equal to 0 because one of those has to equal to 0, because now I need to solve. 3p plus 8 equals 0. Subtract 8 from both sides, and I get 3p equals minus 8. P equals negative 8 over 3. And I set p minus 2 equal to 0. Plus 2 plus 2, p equals 2. So here are my two solutions. However, last thing, if p were to equal 2, and I go back up here to my original equations, I'm going to notice that p divided by p minus 2, if p equals 2, that would be 2 divided by 2 minus 2. That's going to give me 2 divided by 0. You cannot have that. You cannot divide by 0. So this is a non-solution. That is a non-solution. That does not work. P cannot be 2 in either of these situations. So this is my only solution. All right.